I only know that I know nothing. Socrates. When we start asking questions, we often come to realize how little we know. The most mundane, taken for granted topic can turn upside down with the right question. Questions are like ships that sail us into unfamiliar territory. It's the strangeness of the question that compels us forward, not necessarily the answers we find. And yet, not every question needs a meaningful answer. Part of the mystery of life is that answers are often slippery and sometimes frequently absent. If answers were straightforward, life would hold little interest. As humans, we have come a long way from being absolutely clueless about the world around us to being hyper-aware of the mysteries of our planet, space, and time. In a span of only 150 years, we went from a society that just barely scratched the surface on electricity to one that has the internet right in the palm of our hands. But despite all the data streaming in from observatories around the world, there are still a lot of unanswered questions that we're getting no closer in finally answering. But sometimes asking questions is more important than finding answers. Here are 5 unanswered questions that have stumped even the most brilliant minds that have ever existed. What came before the Big Bang? The greatest discovery in history of science is that there was a day without a yesterday. The universe has not existed forever. It was born. All matter, energy, space, and even time was the size of a peach called singularity, a point of infinite density which had a temperature of over a quadrillion degree before it burst into being in a gigantic inferno we now call the Big Bang. 13.8 billion years ago, during this first tiny fraction of a second of the universe's existence, the inflation model says that the universe expanded like a balloon, doubling in size again and again before slowing down to its normal rate of expansion. But if we try to look back before inflation, all the way back to time zero, general relativity breaks down. This means the Big Bang picture is incomplete. There's a puzzle piece missing, and that piece is the earliest moment of the universe itself. But as we try to push deeper and deeper into the first moments of our cosmos, the math gets harder and harder to solve, all the way to the point where it just quits. So the question is, what came before the Big Bang? You might have guessed it. There's this textbook answer that the question itself is meaningless, just as meaningless as asking what's south of the South Pole. The idea is this: if time itself began with a Big Bang, then it makes no sense to ask what came before. There simply was no before. And yet hardly anyone finds that answer satisfying, right? That's why contemporary scientists theorize about striking parallels and believe that the universe expands and contracts in endless cycles, bouncing back each time that it shrinks to a certain size, about once every trillion years. If this cyclic model is right, the Big Bang wasn't the beginning, just a transition from an earlier era. And our universe is just one of countless bubble universes that pop up repeatedly in a multiverse. Which leads us to question number 2. How many universes are there? Philosophers and physicists both have a tendency to push ideas to the limits of what is conceivable. So here's a thought. As if one vast, ancient, and mysterious universe wasn't enough, what if there are multiple universes besides our own? At the end of the 16th century, the Italian philosopher Giordano Bruno speculated that the universe might be infinite, populated by an infinite number of inhabited worlds. And after Copernicus suggested Earth was just one planet amongst others, we realized that our Sun is just one of about 400 billion stars in the Milky Way galaxy, which you can see on a clear night as a pale white mist stretched across the sky. Then we discovered that our galaxy is just one among countless more in an expanding universe. And now recent theories in physics, including one called string theory, are telling us that there could be countless other universes built on different types of particles with different properties following different laws. Are you still following? However, most of these universes could never support life and might flash in and out of existence in a nanosecond. They exist somewhere else in space and time, or in other dimensions. But nonetheless, combined, these parallel universes make up a vast multiverse of possible universes in up to 11 dimensions, featuring wonders beyond your wildest imagination. The leading version of string theory predicts a multiverse made up of 10 to the 500 universes. That's a 1 followed by 500 zeros. But even that number is minuscule compared to another number. Infinity. Some physicists think the space-time continuum is literally infinite and that it contains an infinite number of so-called pocket universes with varying properties. In other words, an idea that started out as a mathematical convenience ends up implying that there's no such thing as individuality. And at this point, we haven't even touched upon quantum theory, which adds a whole new wrinkle to the multiverse question. This theory has been proven true beyond all doubt, but interpreting it is, to say the least, challenging. I mean, who are we to judge what is weird and what is not? Scientific ideas stand or fall not by how they feel to us, but by experimental testing. And that is the problem. An alternative universe is separate from our own. So, the trouble, virtually by definition, we probably cannot ever visit these other universes to confirm that they exist. And it's unclear whether experimental testing or astronomical observations can ever settle the matter. However, the only meaningful answer to the question of how many universes there are is one. Only one universe. But a few philosophers and mystics might argue that even our own universe is an illusion. So as you can see, right now there's no agreement on this question, not even close. All we know is the answer is somewhere between 0 and infinity. And this makes question number 3 even more challenging. Why can't we see evidence of alien life? On a clear night, staring up at the stars induces a sense of simultaneous wonder and insignificance. Humanity, time and time again, finds itself lost amid the vastness of a universe that we are still struggling to understand. Whether there's one or multiple universes, given the vast number of planets and the one universe we live in, why haven't we seen obvious signs of alien life yet? Where is everybody? This famous question, called Fermi paradox, asked by physicist Enrico Fermi in 1950, basically states this. The apparent size and age of the universe suggests that many technologically advanced extraterrestrial civilizations ought to exist. However, this hypothesis seems inconsistent with the lack of observational evidence to support it. On Earth, we've seen how dramatically technology can accelerate in just 100 years. If we can go from rudimentary wooden tools to these feats of engineering in under 1 million years, surely there would have been ample opportunity in our 13.8 billion-year-old universe for other civilizations to have progressed to a similar level. Spreading out across the galaxy, perhaps creating giant energy-harvesting artifacts, or fleets of colonizing spaceships, right? One may think there would be some lingering radio signals or visual clues of their expansion reaching our telescopes. And yet we see no convincing evidence of any of it. Do humans lack the appropriate technology to detect life elsewhere? After all, it has only happened once on Earth in 4 billion years. Maybe even that was incredibly lucky. Maybe we're the first such civilian in our galaxy. Or life elsewhere could be so alien that we are unable to recognize it as such. It also could be that other civilizations deliberately avoid communicating or aren't even able to contact us. Some scientists have argued that intelligent civilizations similar to ours could have gone extinct because of the same dangers that threaten humanity on Earth. As philosopher Nick Bostrom has explained, this concept suggests that life on an Earth-like planet has to achieve several evolutionary transitions or steps before it can communicate with civilizations in other star systems. But an obstacle or barrier, a great filter as it's called in his line of thinking, makes it impossible for intelligent species to progress through all of those steps before collapsing. We may never find anything in our search for aliens except their remains. In other words, evidence of extinct civilizations. After all, it's far better to look than to assume there's nothing to be seen. But even if we are alone, craving knowledge and understanding by asking questions is what pulls humanity forward. So here's another. Maybe all the action takes place inside the mysterious dark matter that appears to account for most of the universe's mass. So, what is dark matter? At the Gran Sasso underground laboratory, deep beneath the Apennine Mountains of central Italy, scientists are keeping watch over a giant tank filled with 3.5 metric tons of liquid xenon. Their hope is that exotic particles from deep space will whisk through the liquid, emitting a telltale signal. So far, that hasn't happened. But scientists hunting for so-called dark matter have learned to be patient. It's been nearly a century since astronomers studying distant galaxies first noticed something odd. The galaxies seem to hold more matter than could be accounted for by the visible material, like stars and gas clouds. While things like human beings, the Earth, the Sun, and everything that emits or absorbs light in space are all made out of normal matter, including particles like protons, neutrons, and electrons. That only accounts for 1/6 of all the mass in the universe. The remaining 5/6, the overwhelming majority, is dark matter. This bizarre ingredient does not emit light or energy. So what is this stuff? We are much more certain what dark matter is not than we are what it is. And the best guess is that it's made up of some kind of fast-moving particle that barely interacts with the ordinary matter that makes up the stars and the planets. Theoretically, these weakly interacting massive particles, short WIMPs, can pass through ordinary matter like the Earth and its inhabitants, which is why we spent millions of dollars on extremely sensitive detectors like the one at Gran Sasso. But if scientists can't see dark matter, how do they know it exists? Thanks to an effect known as gravitational lensing. Einstein's theory of general relativity tells us that space-time itself is distorted by mass, which is an effect that we see as gravity. Everything in the universe is affected by it, even light. So even if we can't see the matter itself, we can see the way light bends in its presence. So far, however, scientists have been searching for these exotic particles for decades now, with no luck. No wonder some are beginning to wonder if dark matter exists at all. Instead, the reasoning goes that Einstein's theory of gravity may require some tweaking. A number of alternative theories of gravity have been put forward in recent years, but all remain controversial. And so, the particle quest continues. Which leads us to the last question. How does gravity work? It is a force to be reckoned with. An extended chirping sound, lasting less than a second, emitting from a monitor in Louisiana, followed by another identical chirp, heard 7 milliseconds later in rural Washington. 20 milliseconds of data that enabled scientists around the world, including Cambridge researchers working with a laser interferometer gravitational wave observatory, to listen as two mind-blowingly large black holes, 1.2 billion light-years away, circled around each other, accelerated from 30 to 250 times a second, and then collided, creating one enormous black hole. The impact caused a ripple in space-time, a gravitational wave. Their findings, the first ever detection of a binary black hole, the proof that gravitational waves exist along with a ripple in a space-time continuum that was predicted by Einstein back in 1916. This unlocked a new door to our understanding of gravity. Although it was the first force to be described mathematically by Isaac Newton in 1687, we still do not know how it really works. In other words, we know what it does, but not what it is. The best modern description is the general theory of relativity. At its simplest, gravity is one of the most basic things of all time. You throw something up, it comes back down. But in reality, gravity makes very little sense at all. It is crazy how gravity can be so incredibly weak and incredibly strong at the same time. Gravity holds the entire universe together, and no matter how far out you travel, it never completely disappears. And yet, it is the weakest force in existence. For example, you know when you bring two magnets near each other and they snap together? That force is actually 10 to the power of 36 times stronger than gravity. But the biggest gravity mystery out there is that once you get down to the level of atoms and molecules and even smaller stuff like quarks, gravity stops working. It is without a doubt one of the true mysteries of science. Questions can be like earthquakes, making people who thought they walked on stable ground suddenly look for shelter. But our very nature suggests we should question. As humans, we are introspective and curious, which separates us from animals. Our intellect is not merely a cleverness to build tools, but an intellect that comes from the questions we ask. If it defines our nature, why should we shy away from asking questions? Stay curious. If you found value and enjoyed watching, give this video a thumbs up and subscribe for more videos.